Good morning. For this assignment, you will be solving radical equations. Um, there are several radical equations listed here. So let's remember the steps is to first isolate the square root, then square both sides, and after squaring both sides to cancel out the square root, you solve for x. Right? So each of these can be solved that way. Isolate the square root as best you can. The last two has two square roots. So the rule there, remember, is simply that there is one square root on both sides. Each side, there's only one. So this is already written like that. Once you've found your solution, remember that you need to check for extraneous solutions. That's where you solved it correctly, but doesn't pass the check. If that happens, that means that it's actually not a solution to the equation. It's an extraneous solution, so an invalid solution, as opposed to a valid solution. All right, so I'm going to solve this first one right here. Just go through the steps of how to solve these. So I look at the equation x equals square root of x plus 6, and see that the square root is already isolated on the right side. So I'm going to write that out. And then I am going to square both sides, right? So x squared equals the square root. Again, this is how I suggest writing your square roots, typing it if you're typing them out. Indicate. Okay, so we on the right side, it's still x squared. On the left side, it's x squared. On the right side, it cancels out, so you have x plus 6. Okay. Now, since it has x squared, it is a quadratic, so I'm going to move everything to the left side. So I have x squared, be minus x, so it's minus x, and then minus 6 equals 0. Right? I simply subtracted x and 6 from both sides. Okay. So first I check if it's factorable. So in this case, what two numbers multiply to get negative 6 and add to get negative 1? Well, negative 3 and 2 multiply to get negative 6 and add to get negative 1. So we get x minus 3 and x plus 2. Right? Now that I factor it based on the zero product property, I can get the solutions. X equals 3 and x equals negative 2. Right? Okay, great. So we have those solutions there, but now we have to check these solutions, and we have to check both of them, right? See whether each of them is extraneous or not. So again, you plug it into the original equation and you just simplify, right? Don't solve, just simplify and see if you get the correct answer. So first we have 3. So if we replace x with 3, we get 3 equals square root of x 3 plus 6, and that's 9. 3 equals square root of 9. 3 equals 3. Okay, that checks out. So that is a valid solution. Okay, and I'm going to, now let's check the other one. So let's plug negative 2 into the equation. We get negative 2 equals square root of x plus, actually 2 plus negative 2 plus 6. Negative 2 equals the square root of 4. Negative 2 equals 4. And that is incorrect. That is an extraneous solution. So, and notice, as I mentioned, that extraneous solutions usually involve a negative somehow for these ones with radical equations. That's correct, that's not. So we can, let's say, somehow indicate that x equals 3 is the correct solution. Let me draw that a bit better. There we go. And somehow mark this one as extraneous. X equals -2 is extraneous. So we only have one solution for this. This one's extraneous. So this answer is X equals 3. All right. So you're going to go through each equation and just solve it. And then again, check if it's extraneous. Each solution if it's extraneous. All right. So just do your best. Ask if you have any questions on this assignment, and you can message me or attend tutoring or schedule tutoring time to work on this. All right, so have a good rest of your day, and I will talk to you next time.